Hey, how's it going? In this video, I'm going to be talking about selective laser sintering and what that is. Selective laser sintering (SLS) is an additive manufacturing or 3D printing technology. That means we're going to be adding material, not removing, but adding. Used to create three-dimensional objects by selectively fusing or sintering layers of powdered material. It is a popular method for producing complex and durable parts, particularly in industries such as aerospace, automotive, healthcare, and product design. Let's take a look at some of the key features. Process. SLS begins with the bed of powdered material, typically thermoplastics, polymer, metal, or ceramics. A high powered laser selectively fuses the powder material layer by layer according to 3D computer aided design CAD model. Layer by layer fusion. The laser is directed to the specific area of each layer where fusion is required based on the design. As the laser passes over powder material, it heats it to the point of sintering, causing the particular fuse together and form a solid layer. Powder bed. After each layer is sintered, a new layer of fresh powder is spread over the previous one. This process is repeated interruptedly until the entire object is built up, with each layer fusing to the layer below it. Even now, if I'm talking with someone on the video call and the lady, if she's from US and she has a very unique understanding as to some of the British or American words, right? And if I'll pull out some of my accent or thick accent words, people would struggle, I guess, at least in the beginning. After time, they might get used to it, my accent and everything. Depending on the words and how I'm using it and what context is perhaps it's a lot easier to understand some words than others. Support structure. SLS doesn't require support structures like some other 3D printing methods, i.e. fuse the deposition molding or FDM printers, because of the unsittered powder acts as support to the object during printing. This reduces the need for post-processing work to remove support. Right. This particular process that I'm talking about right now, they would use powder, similar to liquid, but that would be powder, where it would be space would be filled up with powder. Some of the other ways how to manufacture goods we covered already, where it would be a tip which would be heated and potentially produce particular design, where in this particular instance we will be talking with powder, depending on what problem you're looking to solve, how fast you would like to solve that problem, what's your budget, and what are opportunities out there, because this equipment, I believe it's not the cheapest compared to other alternatives to that. Material versatility. SLS can use wide range of materials including various polymers, i.e. nylon, polyamide, peak materials, i.e. aluminum, titanium, and ceramics. I think most of the time it's for high-end materials. I believe this method is used, or at least I have seen and heard of people using this particular method of manufacturing, where they're using high-end materials, since all the, from what I understand, the equipment is very expensive compared to alternatives of that. The choice of material depends on the specific applications and desired properties of the final object that you are going to be manufacturing. Complex geometrics. SLS is well suited for producing complex and intricate designs, including parts with internal channels and structures that will be difficult or impossible to create using traditional manufacturing methods. Durability: SLS produced parts are known for their durability and strength. This makes them suitable for functional prototypes and use parts and components subject to mechanical stress. Uh, that from my understanding, yeah. So most of the time that will be used, especially if there would be a lot of intricates or whatever. But I believe currently that the all equipment is slightly too expensive within the market. I think it's a great way of doing it, but perhaps there needs to be more attention within the space so the equipment can get cheaper, and hopefully that's something that we're looking to achieve in the near future. Accuracy and resolution: SLS can achieve high levels of accuracy and resolution, allowing for fine details and tight tolerance in printed objects. Post-processing: while SLS parts typically require less post-processing than some other 3D printing methods, they may still need surface finishing or additional treatment depending on specific application. Production applications: SLS is used in various industries for prototyping, custom manufacturing, and low to medium volume production. It's particularly valuable for rapid prototyping, where multiple design interactions can be quickly produced and tested. Currently, we just to most extent, so to some extent, we're focusing more of prototyping, I guess, or low volume manufacturing. We can in the future progress into large scale, but those people in the space perhaps they are already aware of that entry level would be over £1 million, dollars, euros. So entry level, where right now we're discussing where very little entry level compared to large scale output or volume and what would machinery would be in those particular instances. We can touch on those as well. I have a lot of experience and I have understanding how to operate and manage those machines as well. But currently we're focusing on small or medium output and based on time, volume, and capabilities. So let's focus on smaller scale first. For those of you who would like to learn more, I'm sharing a lot of information in a book. I have published a book. The name of the book is Game Strategy. In the book, I'm sharing a lot of information about the people, for people who would like to learn more, as well as understanding markets, future markets, and where all industry is going to be within the next 5, 10 years, as well as I'm doing assessment where industries are right now, as well as where the thing's gonna be. This book designed for people who are interested in bettering themselves as well as earning a living, perhaps, or starting a business, investing in different businesses. All this book of content is tailored to those group of people. Perhaps if you're currently working for yourself and you're doing research, what will be required of you, eventually you need to start understanding and perhaps taking more responsibility and starting a business. Hopefully, then we can work together. You can find this book in the description as well as Top Retailers has it. Let's take a look at some of the sectors and what sectors and where we could potentially use this selective laser sintering manufacturing method. That would be aerospace industry. They could use that for prototyping and use parts, as well as medical and healthcare, custom implements, SLS employed to produce custom orthopedic implants such as hip and knee replacements. Just some of the examples which potentially can hold a lot of stress, which I completely agree with. Automotive industry, functional prototyping, as well as spare parts, consumer goods, customized footwear, uh, product designs. Footwear, I don't know, perhaps small scale sampling, perhaps, or not necessarily that's the best option for that, but there's potential there. Architecture and constructions, architectural models, custom breakers and connectors, perhaps education and research, educational models, as well as research prototyping, perhaps maybe dental industry, yeah, sure, dental prosthetics, as well as art and design, sculptures, artists and sculptors use SLS to create intricate sculptures and art pieces that will be challenging or impossible to achieve with traditional methods. Perhaps there's a potential there as well. Uh, I would highly recommend for those of you who are within any particular industry to do a little bit more research, perhaps check online about entry level prices and what might be your budget that you're working with. Other than that, thanks for watching. I'll see you next one.